from my side. My colleague Julia is recording this session because we're recording all sessions to share the knowledge also afterwards with the people who could not attend. Enough from my side. I'm very happy to welcome Tamás Lovas from BME today as our guest speaker. He will give a talk on cooperative learning and teaching, so how to include university external players to the university stage. I'm very happy that he's on this topic with us today, and I will just give the stage to you. Tamás, welcome, and the stage is yours.
Thank you, Eike, and thank you for FAU for organizing this meeting. Let me share my screen. I think you see it. Just let me know if the signal is faded or something. So I'm from the Budapest University of Technology and Economics, and I think we need to put my presentation in context. So let me introduce shortly the university. This is the largest technical university in Budapest. It has 8 faculties, like the departments. I mean, in faculties, not about the staff. So 8 faculties. One is social and economic sciences. One is natural sciences. All the other 6 faculties are engineering faculties. And I'm from Faculty of Civil Engineering. I'm the Vice Dean for Education. I don't know how it works at your university, but Vice Dean for Education is a rather administrative post. Like people at conferences think that Vice Dean for Education is dealing with how to develop the education, what to teach 5 years later. But 90% of my job is managing the requests from students and managing human resources and the schedule of the next semester and whatever. But I'm really happy to deal with such programs too. And when I was asked from BME side whether we are able to participate in this knowledge bites, I was rather selfish because I selected a topic what I'm really interested in cooperative education. We are, as always, in the middle of refreshing our education programs and curricula. And this is a very important part, I guess. And under cooperative education, I mean in collaborating with the industrial partners in education. So I will not talk about R&D or something. If you just Google this expression, cooperative or university industry cooperation, it's mostly like technology transfer, R&D, whatever. But I'm now focusing on the education part. And our faculty is, I think it's a European sample, but 20 years ago, civil engineering faculties and departments received huge number of students. And unfortunately, in the last 10 years, the number of students of civil engineering departments are decreasing. And actually, in the recent year, we received 200 BSc students and like 100 MSc students, and plus 1/3 of international students. Okay. So I will talk about the motivation of industrial cooperation, the current solutions we apply currently, like technical internship, whatever. Why is AEC, architecture, engineering, and construction field is special? So how to have industrial cooperation in this field? Why is this different from, for example, the automotive industry? What is cooperative education? If you want to narrow down this field and not talking about dual training or whatever like you have in Germany or whatever, but what is cooperative education? Why can it be a good solution? How to assess the learning outcomes and the competencies students can gain at an industrial partner? So I will talk about the assessment, recognition, and the credential system that can effectively support this, and why is it important in ELISA. So motivations, cooperating, if students can gain competencies, learning outcomes at an industrial partner, it's like the learning by doing. We always say that you can learn something by doing it, by try it. That's why we have not only lectures and presentations, but we have the labs and the practical training. And there are no sufficient opportunities in the current BSc, MSc programs for that, because we need to keep the deadlines, keep the schedule, and give the lectures. The theoretical background is so big that when I'm talking about my professors, who were professors in the 80s also, they are telling me that, for example, in reinforced concrete structures, it's a subject in the Faculty of Civil Engineering program, the material, the topics was much lower in 20 or 30 years ago, because professors and lecturers want to give everything what they learned in the last 20 years, want to transfer to students, and that's why the programs became very fragmented in the last 20 years, and that's why we don't have so much opportunities. So there is no space for that in our curriculum. And that's a demand for the industrial partners, that they want job-ready engineers. And that's an illusion, I know. And I think they are not right. The university's main task is not to give work-ready engineers to the market immediately after graduation. But still, if one student is working or training at an industrial partner, the training period will be less after graduation. Few professors has industry experience. That's country specific. For example, I like the German model. I was a PhD student in Germany, because it's rather common that in Germany a professor has they're working at an industry for 10 or 20 years, then return to the university, and then that's the way they can transfer the knowledge they gained at the industrial practice. But like less than 50%, but many professors has very low industry experience. They, like, after PhD studies, they remain at the university doing some research, but they didn't have, for example, they don't know nothing about the corporate culture. Yeah. Secondly, when a student is working at a company, the knowledge will be more focused on the learning outcomes. We all know what ESCO is, right? It's like a dictionary of skills required from different professions. This is the European dictionary. I don't really like it, by the way, because when we have the task to pair the ESCO skills and learning outcomes with our programs learning outcomes, I see it's very disproportional. And there is sustainable development goals, which is in the main focus of ELISA also. We can pair it with the knowledge that can be gained at a company. And to be honest, if you want to be up to date, many times I say that we need to teach not only civil engineers with the skills not only needed now by the industry, but we need to give competencies to them which will be needed 10 years later or 20 years later. We teach students for unknown professions. Maybe there will be very new areas they need to work on. We still don't do not exist now, but still the industry has the capacity to know the up-to-date technologies in the field, and that's can be gained only at their side. And if we want to teach the skills required by the industry, that's the best way to do them. There is a standard complaint from the companies that the students graduated at our faculty, they have less skills in soft skills. They don't have soft skills, leadership skills, coping skills. For example, keeping the deadlines. Students are full with deadlines, but keeping it, they are always requesting extensions, retaking, whatever, and it doesn't work in the corporate culture. They don't know what a corporate culture is, how to communicate with the leaders, how to approach a new problem, how to cope with a problem if something doesn't happen as was expected, and practical skills like documentation, because since our curriculum is overcrowded, we hardly can fit the many learning outcomes we expect from students. We don't let them, for example, to write so much documentations about the home assignments and whatever, and this is missing from the industry. One other thing is, this is working at an industry during university studies is attractive to students. I think you observe the same, that the currently applied teaching methods is not attractive to students. It is just boring, like sitting 90 minutes in a classroom and seeing a PPT or videos or whatever. I can dance before the board, but it's still boring because students got used to Instagram and Facebook and whatever, many information just flashing in, flashing out, and it's not attractive. So to resolve this problem, I think the US model is very good, focusing on project works, focusing on teamwork. If you let the students work on their own and not forcing them on contact hours in the university buildings, but let them work on their own, it can be attractive. And working at a corporate environment, it's attractive to students. Sharing the costs. It's not only for the society. Obviously, if the student is not here, but at a company, it's not my time, right? I maybe I'm helping in writing the contract with the industrial partner. Maybe I'm participating in assessing the competencies, and maybe I'm doing the educational administration. But the student spent her or his time at a company, at not my time. But it's also cheaper for the company because, okay, they pay the salary for the students, but they can reduce the training cost, what is now given after the graduation. So it's very important that sharing education costs between universities and companies is for both. And okay, I told you that I won't talk about the R&D and the knowledge transfer, but still, if my student is working at a company, then I have a contact with that company. I have a contact with a supervisor for my company. So I will get information about the company's activities, the technology they use. So they have a direct contact with me. And for example, in a proposal for a EU project, they can find me because they know that we are teaching this and whatever. So education can support R&D this way. Thirdly, our really huge program at our university, the students are working during their studies. I don't know how it works at your country, but we have only full-time programs. We don't have part-time programs. So we have a semester with 14 weeks, and each week we have like 20, 25, even 30 contact hours for students, depending on the education program. But still, even at BSc level, in the last 3 semesters, more than 50% of the students are working. So if they are working, let them work at a partner of us, let them doing activities which are connecting to our education program, let them doing activities which has the same or similar learning outcomes, what we are expecting from them. So I think it can resolve it, let them work, but during working, they can learn. And the construction industry is now rolling, so they can receive as many students as they could receive more students than we have. So they can give them value work. They don't use our students for example, use copying documents or whatever. They are giving them engineering tasks, so we can assess them. Other thing is professional identity. We need to reduce our dropout rates. That's the expectation from the government also. If the government pays, for example, most of the civil engineering students are governmentally financed, so the government pays the tuition fee for them. And the government expects us, if 200 students are admitted to our program, don't let them drop out, and don't let only 100 students graduated 4 years later. Okay, so that's reducing dropout rates. And research show that if you want to reduce the dropout rates, there is 2 very important factors. One is professional identity. The students need to understand what the profession is. For example, in case of civil engineering, they need to understand why is it important? Why is it important for the society? Why my work is valuable? And the other one is community identity. So the student cannot be isolated during the studies. They need to feel themselves in a community, direct connection with professors, connection with other students, with other communities, whatever. And professional identity in some professions is very hard to receive. For example, talk about architectural students, architects, okay, departments of architecture. At the first semester, they are sitting in the old building of the university and making drawings of the buildings. They feel how nice it is. I'm an artist, I'm an architect, whatever. Civil engineering students, 2 years of calculating, computing, very hard, very boring. And after the fourth semester, we can let them design a bridge or whatever, and then they feel, okay, I like it, whatever. And at the industrial partner, they can find their professional identity faster. Repeating learning cycles. This is the fourth time I mentioned that our curriculum is very crowded. It's hard to fit in new knowledges and whatever, and there is no time for repeating the learning cycles. There is no time for practicing each week, whatever. If, for example, in statics, we have the learning material, until the first test is like 4 weeks. After the 5th week, we are building upon the knowledge they gained at the first part of the semester, right? We don't have time for repeat it again, whatever, like in high school, because that's effective. And in the industrial partners, they have repeating tasks and cycles, so they let the students learn what they need to. Okay, what are the current solutions we have? So in case of industrial cooperation, we have obviously the internships. Okay, at BME, at the technical trainings, 3 weeks of technical internship is required from students. The 3 weeks should be consecutive weeks, so week after week. So that's why they do it in the summer after the 3rd year. So after the 6th semester, it's 0 credits, but it's a milestone. So it's mandatory to complete until the graduation. We can have guest lectures from the industrial partners. The problem with guest lectures that they cannot be as consistent as the professor do. It cannot be fit as smoothly in the program of a subject of a course than in case of our own subject, right? So it can be resolved. So if you discuss it very thoroughly with the industrial partner, then it can be better. At BME, we have the position of industrial professor. So even not having a PhD or any kind of academic degree, but they have achieved enough achievements to being able to teach it. Actually the level is very high, so it's like state, I don't know, grades or whatever. Then they can teach at the university. And for example, main designer of a Danube bridge is not having any academic degree, but in this way, I can allow him to teach to my students bridge engineering, right? Dual education, dual training. It's working in Germany, I know, because I think Hungary kind of copied the German model in case of dual training. In dual training, students spend more than 20 weeks per year at a company. They need to go through a selection process, so it's not automatic. They are receiving salary, but the partner companies have to be accredited. So in case, for example, if in informatics or mechatronics or vehicle engineering, it works. It works like this way. They spend like 20 weeks at the university, then 20 weeks at the industrial partner. But they have to be, the industrial partner have to be accredited. The university need to check, actually not the university does that, but the Hungarian Accreditation Committee or whatever it's called. So we need to check whether they are able to teach, whether the student is able to reach the required learning outcomes. And so it's a very hard process, and it works, for example, in automotive industry, in informatics, in electronics, but not in civil engineering. I will explain why. And that's why we try to apply the so-called cooperative training. And that's what I will show you some examples from. Why dual training doesn't work in case of civil engineering? Although we have nice examples in automotive industry or the IT sector, in AEC, architecture, engineering, and construction, it doesn't work. The main reason is we are not talking about, in case of civil engineering constructions, we are not talking about a factory. We are not talking about a single building with IT infrastructure and with separate offices and whatever. We are talking about construction sites with low digitalization level, because they are outside. They try to have the containers where the engineers are working, and there is weak internet signals or whatever, and there is dust, and sometimes it's cold or whatever. So that's why it doesn't work. The other problem is with the human resources. If you check who is working at a civil engineering construction, the human factor is very heterogeneous. There are not only engineers working at a construction site, right? In case of an IT company, an IT factory, IT company, automotive factory, automotive industry, it's very easy to find people who are working all the time in the building. Students, they can supervise students. In case of a civil engineering company, we have huge offices, design offices, whatever, that they are moving in, moving out. And for example, in case of automotive industry, we have a strict plan. They have a strict plan for 5 or 10 years. And we design, I don't know how it works, but they can design a car for 10 years later. In case of civil engineering, I don't know what will be built in 3 years later and where will we build it, right? So it's very hard to build up a higher educational environment. Okay, and in Hungary has 10 million inhabitants, and we have 100,000 AEC companies, most of them 1 or 2 person companies. So we have actually less than 2,000 who are able to receive students for a technical internship, because due to the Higher Education Act, I think, so due to the law, it's allowed to receive students if you have at least 8 employers. And there are only 20 or actually 23 companies, huge companies. They are having the governmental project who would be able to receive students that way. So that's why in case of civil engineering, the dual training doesn't work, and we don't have it. So what are the alternative way can be the cooperative education. Cooperative, don't talk about only university and employer. The student is the main point. So cooperation between student, university, and employer. And the main point is we need to recognize, we need to accredit the competencies, the learning outcomes gained at industrial partners. It didn't happen only in Hungary. I know it's a European, it was a European plan that we need to much more flexible in this way, recognizing learning outcomes. So, for example, to increase the rate of the mobility. Think about Erasmus. Erasmus students, they want to travel only or spend a semester abroad if the competencies will be recognized, right? In case of cooperative learning, I can cooperate only, for example, in a course. I don't need to have a plan for the whole program. I select a course and I say, if a students have these activities at this company for this duration, I can accredit it and I can recognize it as this course, okay? So we can be on course level or even lower, even part of the course, for the practical part of the course. For example, in a BIM, Building Information Modeling course, the student is working at a company dealing with BIM, and they do it high level. I can check it. The company let me check it, that they give this and this task for the students. Then I can recognize it. I don't need to teach it twice, right? And in this case, there is no need for accreditation, so it's very easy. So we can regulate it by contracts between the university and the company. University can control the activities, of course, and it will be very flexible. I will show you some examples. So it can be a project work. If you see, I don't know whether you see that's a structural engineering curriculum on the right side. So obviously, I'm not talking about mathematics or physics laboratory, not even numerical methods or like core subjects like this. But we have the project works, for example. And in the project works, the students are working. It's like 6 ECTS, so it's rather big in our curriculum. It's like a mini diploma, right? Mini thesis. They have an own project working for 14 weeks, for example, designing a building from the geotechnics through the structure until the analysis of, I don't know, like, for example, energetic analysis. And if the student is working at a company and doing that way for a salary or whatever, I can accredit it. But it can be a part of the course also. For example, a home assignment. Okay, it's not entirely, the learning outcomes are not gained entirely from the company, but from some particles, some parts, if the student is doing that, and they are doing that because they are working, because they need money or whatever, then I can tell you, okay, the second home assignment is not mandatory for you, right? And this is the additional advantage, is like they can learn the corporate culture and the system at the company. Just aside, for example, we have the BIM program, BIM specialization, building information modeling. For those who are working in architecture, field of architecture or civil engineering, they know what it means. It's like using IT systems in a single system to manage all civil engineering, all the construction activities, for example, electricity, architecture, structure of the building, whatever. And these are our partners. And this is very interesting because we have software providers, for example, Autodesk suppliers, graphics software. We have universities cooperating with us, and there are companies from structural engineering, from infrastructure engineering. We are cooperating also with the governmental authorities, for example, about standards and legal aspects and whatever. We have IT companies dealing on this. So this is the bunch of companies cooperating with us. They are very proud of being on this slide actually. So if I show it at a conference, oh, I'm there, that's very good. We can also cooperate with you with BME, and they give us lecture. They are receiving students, whatever. For example, one of our BIM subject is working that way. Just to give you another example how to cooperate with companies. The semester is 14 semester long. After the 4th semester, we create 2 or 3 student groups with 2 or 3 students, and every week they visit a different company for half day or for a single day. They do it for 6 weeks, and they then make a presentation what they experienced. It's a very good way to learn about. So we are teaching BIM. They can check what is BIM currently, what is the state of the art in Hungary in BIM, okay? And then in the meantime, they learn about the corporate culture, how it works. In the position I want to apply for 1 year later, there is a colleague, what is she doing and whatever, okay? So I think it's very good for students. And how to assess the learning outcomes. I think the credentials, if you are involved or if you know what Work Package 3 is doing in EELISA, that you know what credential is. So that's because if a student is working at an industrial partner, I cannot give a test for the student to do the test, do a homework, but I can easily explain to the company, to my partner, that for that learning outcomes or the group of that learning outcomes, I can give a badge for the students. So if they feel that the students fulfill the minimum requirements of learning outcomes, they can give a micro credential for it. Okay, and the micro credentials or credentials can be accepted both by higher education in the institutes and the industry. So I can have an equivalence table between the badges they gained at the company and my learning outcomes at the university. And these badges are coming from actually from the companies, so they can evaluate, they can assess between them. So if a student is receiving a badge from a company, for example, he is able to, I don't know, make a geotechnics model in a software, in Revit or whatever, then the other company can understand this badge that, okay, maybe it's much more easy to understand than seeing a university course being accomplished by the student, right? Because that's obvious to say that the student is able to do geotechnics modeling in Revit, in a software, okay? So that's also in part of focusing on the learning outcomes. And actually this using credentials, it's proved that it's motivating for students. Like collecting collecting currency, collecting values. It's very important. So what are the benefits and downsides of this cooperative education? Sharing resources, that's a benefit. Saving time for students working besides education, so they don't need to learn again what they are learning at the company. It's easy to get a job after graduation. Now the construction industry is rolling, so it's easy to get a job, but now obviously most of them are staying at the company they have the internship at. And of course, it's supporting orientation activities. So civil engineering is covering structural engineering, road and railway engineering, hydrologic engineering, even geoinformatics or whatever. And during the studies, if we let the student work at this company for half year, this company at other year, it supports orienting the student what to select at the end of the program. And there are also downsides, obviously. So not all the time is useful spent at the company. So it doesn't support fully the education. I'm not too idealistic. So I don't think if I let the students work at the company, they can teach them everything, because usually a company have current company demands. For example, okay, I put you on a project and the university expect us to give you value work, and the work at the end with high added value, but still we are focusing, for example, of a metro construction or geotechnics of buildings. Yeah, and how it can be regulated? It can be regulated by contracts with the, we have some experience on that. In the contract with a company, in this so-called cooperative education, we need to fix the duration of the activity, the entry requirements. It's not, it doesn't mean that the students just give the university just send the students for one company. They don't need to, they cannot be forced to receive students, so that it can be a selection process. And in this way, they receive salary, the students receive salary, and both from the university and company side as advisors should be assigned, and the field of activities can be should be fixed in the contract. And why is it, this is my last slide actually, why is it important in ELISA? I think if I mentioned internship, recognition, who are among us, there are some people who are working at ELISA. We can match the connecting work packages, right? For example, work package 3 is education management and accreditation. Work package 6 is internship, partnership, and apprenticeship. So if we want to be a European university, we can manage cooperation with European companies, and we can accommodate the European standards, and we can go for the European recognition. So again, I'm not an expert of this field at all. We are thinking of cooperating with industries. We see the benefits of it, and this is the way we can move forward in a so specific field, which is civil engineering, which is very hard to have, for example, dual training. And thank you for your attention.
So thanks a lot for the presentation, Tamás. There were already some questions in the chat, and first of all, I would like to give the word to Ebru from ITU.
Hello. Thank you for this very nice presentation to Professor Lovas. I wrote my questions while I was listening and watching. I wrote down my questions to chat, so let me go back and check my own questions.
Maybe we could also go to the slides again.
Yeah, one thing is that you mentioned about, which I totally agree, the importance of developing, helping the students to develop or improve the professional identity and the community identity. I totally agree with that. These are semi-technical, and one of them is semi-technical and the other one is soft skills. I wonder how it is getting challenging to manage that process, to support our students in that. in the times of the COVID-19 pandemic, during which we have almost everything sync online. So
Yeah.
how do you think, or how you and the other attendees are handling that?
Okay, that's a very good question. So during the COVID, we were coping the same problems as you did, actually. So without meeting the students, how to develop the community identity. And I think internship can support it, because the constructions didn't stop during the COVID. So the construction sites were working. Okay, maybe there was restrictions in the offices, but civil activities has always on-site parts. So my experience, we were very afraid on the first in 2020 spring, when the COVID was boomed and there was the closure, and we was worrying how could the students do the technical internship, and there was no problem at all, because the construction sites that were working, and they are often open areas, so it was easy to solve. But still, they couldn't work at the offices, because many construction companies has home offices also. So
yeah.
That's it.
Yeah, that is civil engineering is a lucky profession regarding that. How about the others? For example, I'm an environmental engineering professor, and mostly my expertise is biological wastewater treatment. And these are dangerous places to work during COVID-19 pandemic. Even the regular, on-site staff are under the danger of, getting in contact with the aerosols of COVID-19 arising from the wastewater treatment plants. So it is just an example. It is not characteristic of environmental engineering only. How about the other engineering professions which had the as profession and the workforce struggled during the COVID-19 pandemic, has been struggling. And also, so there's a decline in the, as you said, in the offers of the companies for summer internships. The other, not the civil engineering, but some other professions, maybe from the
I don't have direct experience for other engineering fields, but what I know is the government was very flexible at the first year of COVID, and they let the students do the internships not only the summer period. So they asked the universities to be as flexible as possible. For example, we opened all our laboratories in the universities for the internship. It's not at a company, we know, but it's better than nothing. So we have some research activities at our laboratories, for example, in the structural engineering laboratory, and we let the students do the internship who couldn't have place outside. And from the side of the educational organization, on the fall semester of 2020, you remember that was not full closure, because after the summer, the COVID situation was allowed, and we started in a hybrid system. So part of the classes were online, other part was face-to-face. And we preferred first-year students being at the university, because so the first preference priority, the first-year students had higher priority to attend face-to-face classes. So that's what we could do. Last spring, so the last year spring, that was total closure, that was totally online. And now we are in presence.
Okay, maybe I can also add something to that. I'm not coming from the engineering direction, but I was in the IT environment before I started to work at the university, and we also had some working students in my team, and there it was easy to let them work because they just needed their computer. But what was actually a major issue was data protection and so on, because usually the working students were the ones who were not allowed to work from home, because they were only there for a short time, they were not full-time employees and so on. And then suddenly the company was faced with they had to like send them home, and they didn't have the hardware at the beginning, they didn't have the software, then the problem of IT protection came up. So this was like a big issue, but I think it's something we have to deal with in the future, because from my point of view, it will be like we will continue with this hybrid format. It will not get all lost. So we will have a little bit more digital, we have a little bit more maybe not being in the place where we work actually to work there. But yeah, exciting how it will continue the next years, because it's probably not a one. We already have made the experience. It's not a 1 or 2 year thing, but it will probably continue, or at least a little bit longer.
Yeah, I agree. There's no going back, I guess.
No, not totally, at least.
No.
I think partially yes, but yeah.
Mhm.
Are there any other, or are there other questions at the moment? Because I would have a question, because you mentioned the German model quite a lot, and I'm not sure how it is actually in Turkey and Spain and Hungary, but in Germany we have like 2 types of universities. We have like the research academic universities, and we have this universities of applied sciences and technical universities or schools actually. And FAU is a academic scientific university, and all these kind of universities you could say that they tend to be a little bit arrogant, because they say we like the better ones, and there's always a fight between these two. And the other kind is like very much more on practical knowledge, and they all have they have to have internships and so on. And the schedule is much more fixed. So at university we have much more ways to choose. But when I say, for example, to my colleagues, we want to do practical knowledge, we want to include challenges and include companies, many of them say, that's the thing of the other, the thing of the applied universities, and we don't do this, we do like real research and science. And do you have and the first question is it in the other countries the same? Do they have the same model, or is it like just one type? And second question, how can I approach these concerns of these people? Because I think practical application is indeed really, really relevant. That would be my 2 questions.
We have also science or research universities, and actually these are huge universities having many disciplines integrated in them, but not engineering. So for example, civil engineering, they are only at the technical universities. I don't have much experience on that, but I know that in you called University of Applied Sciences or whatever, you have they have very good industrial cooperation models in Germany, because that's. And the other thing is the government. The current government highly supports applied science. So they prefer to do what is expected from the industry. Okay, so they support these kind of activities. Actually, the dual training was their invention in the last 10 years. So now it's highly supported. And what is going on now is building science parks between next to the university. It's not geographically next to the university, but the universities has to collect industrial partners for doing common research, and it is supported by the government. And I think that will support also the education, because I have a good contact with a company with scientific cooperation that I will have the benefit of the cooperation in education.
How is it in Turkey?
I was just writing to the chat. I'm from Istanbul Technical University, and so apparently from the name, it is we have a very, very similar structure like you have in Germany. We have the technical universities with majorly engineering, providing engineering education. However, maybe the content or the curriculum might be different. And then we also have the other type of universities as well. And then we have like more science oriented, pure science oriented, and then we have the medical schools.
Mm-hmm. And ITU is like the technical oriented one. Or,
yeah, it is a tech one.
Yeah, because usually in Germany they're also very small, and ITU is like huge from my knowledge. So
yeah,
the models I think still a little bit different.
I think currently we have 40,000.
I think it was even 50 the last time I checked.
Yeah, it is
incredibly
increasing. Yeah.
Yeah. And I think there's also this techno park next to your university, right? Or is it? I don't know if it's next
We
to it.
have
But...
we have a couple of them, 7, I guess. Within the campus, within Maslak campus, we have 7 of them. Some of them are small scale, some of them are really big scale, and in majority of them, 2 of them are niche, thematic. The others are general, and there are companies from outside as well, and also from companies like branches of, let's say, Ericsson has an office within one of the technoparks. And then we also have companies owned by the university professors. Because it has, having a technopark has some financial advantages for the company owners, lower taxes and things like that, or waiver from taxes. I'm not sure. I'm not very good with money issues.
All right. I would have actually a second or third question, because in the morning, our account manager for Siemens, or the university relationships between FEU and Siemens, wrote me because they would like to reach out to the ELISA ecosystem, and he said he would like to, or they would like to do a lecture series on one topic. The topic is not fixed yet, and have an impulse lecture from somebody from Siemens for, I don't know, 50 minutes, and then have a research part, or on the same topic, a research lecture part from professors coming from the ELISA universities. He was asking me if I think it would be possible and if we could do this. What are your thoughts on this? How could I best introduce it, or should I just write to the, I'm not sure to whom should I write, to work package 6 in ELISA? And you said you also brought up the example of lecture series and said, like, yeah, it's nice, but you don't have so much engagement. I think that's kind of true, but I think especially for international involvement could be a good way to have them, at least for the beginning, online, and to include different speakers from so different professors from different universities and also different industry partners. Yeah, he also sent a link from something what they are already doing. I just posted in the chat. So maybe the question would be, would that be of interest to you, and who could I talk to you at your university best? I think Tamás is frozen. No.
Yeah. Now, based on the topic, I can connect you with the relevant departments, obviously. So but if it's online, and it can be the thematic is fit in some of the education programs, I think it's yeah. all the faculties have international students, so it can be an exclusion that it's in English. That's no problem.
But it totally depends on the topic, and I would approach you as a contact person first, and then you would establish the contact. So that would be like the easiest way to
yeah, of course. I have contact for all the faculties, so sure.
That would be great. All
so
right.
I was not frozen. I'm checking this LinkedIn link what you send me. It's yeah, it's yeah. rather like for the mechanical engineering and electronical engineering, informatics. Okay.
Yeah, it was just an example, but he said like something like this, it would be nice to do it in the scope of ELISA, and I think also it would be a nice idea.
Yeah, and it can be awarded by credentials if we finally have the system. So yeah.
All right. Are there any other questions at the moment? No. Okay. We are 5 minutes early, but I think that's perfect because then I also have some time.
Yeah.
to get lunch. Thanks a lot for the presentation again to Tamás, and thanks all for joining us and for being here today with us. If you have any further questions or want to learn more about ELISA, you can write an email to us. I just posted in the chat. Give me a second. Or if you also want to like introduce your own knowledge bite, we are also always open to that if you want to be a speaker yourself. We will meet in 2 weeks again, and then the topic will be on communication. You can also find more information on the next Knowledge Bite on the EELISA website. Yeah, that's basically it. Thank you very much, and see you maybe in 2 weeks again. Bye.
Thank you. Thank you for your attention. Goodbye.
Bye.
Bye-bye.